July 5th. Kind of proud of myself. I read this entire book. It's 258 pages, and a few notes I made for myself. One of those things is the decisions and responses from the IAU in regards to astronomers wanting to understand what their decisions are going to be, when the decisions are going to be made. Even when the inquiries are made by professional astronomers, they're mostly ignored. They're just, say you're a professional astronomer, and in this book, they want to know what decisions they're going to make concerning the naming of Pluto. 1 year passes, 2 years passes, 3 years passes, and there's no real response from these types of organizations. And what usually happens is that you have this large group, and then they form these little tiny committees that make decisions based off of specific little things. And so it kind of branches off in a leaderless, haphazard fashion. I guess they don't want to really have a leader in science. I don't know why. I guess mob rule is the best. And one of the most disappointing things is, yes, I read every single page in this book in depth, and I looked for the answers. Besides him just teaching a geology class and flying by the seat of his pants because he's not a geologist, he was learning as he went, he never really mentions the differentiation of these objects and being able to classify them based off of their differentiation. So you have a planet being organized structure, and sometimes you find impact remains, which is completely unorganized. So you have a little smiley face there, a planet, and an impact remains. So if he really wanted to figure out if Pluto was a planet, all he had to do is find its moment of inertia. If it's differentiated with a large iron nickel core, then it's a planet. If it's undifferentiated and the material is all over the place, like Callisto, one of the moons of, I think, Jupiter, then it's an impact remains. It's that simple. So all this mess about how massive it is and all this stuff, that could have been circumvented very, very easily. But it's never mentioned. The internal structure of Pluto, the internal structure of these other objects is never mentioned. I guess taking the moment of inertia measurements are not available? I don't know. I'll have to look that up. But that's all you really need. And then you can classify them based off that. Another idea in here I learned, creationism. The naming for planets or large objects in the solar system have to come from creation myths. And what that does is reinforce the culture of creationism, of Big Bang creationism, of, everything just popping into existence. It reinforces the culture of mythology. And I don't think that's a healthy culture to have inside of the sciences. I think if we're going to move on past the misunderstandings and bring humanity to new levels, we have to get away from thinking in terms of mythology and thinking that that somehow defines us. I don't know why we have to name things off mythology anymore. We're not defined by mythology anymore. We have an advanced society. We've been to the freaking moon, okay? We flew past Pluto with a spacecraft. Juno is about to orbit Jupiter. They don't have to be mythology names anymore. We can change the names of these freaking things if we want. But nobody ever mentions that, I guess. The culture of creationism is alive and well. And another disheartening thing, slowly have come to the realization that if it takes 70 years to reclassify Pluto to something other than a planet, because Pluto was discovered in 1930 by Clyde Tombaugh, I think it was. If it takes 70 years just to reclassify a rock from Pluto to something, or from planet to something else, they're never going to figure out how stellar evolution works. They're never going to figure out that a star is a young hot planet unless something really drastic changes. But the way I see it right now, tradition is so well absorbed into the culture of creationism, of Big Bang, of dark matter. Somehow we're supposed to believe that it's there doing magical stuff. I just don't see it happening in my lifetime. I don't see them understanding what they're standing on ever. Uh, I'm pretty sure I'm going to be a fossil before these idiots understand what's going on. Hopefully, maybe I should maybe I should get a stone tablet, like a granite tablet, and inscribe the whole theory onto the granite tablet and bury it somewhere, in case an EMP takes out a lot of internet servers and the theory just disappears. All my work vanishes. Or I could figure out a way to make this paper into a fossil-like structure. But that's this dumb. Another idea was I learned in here that the people who announce the discovery get to have the discovery as their own. So, for instance, if you're an astronomer in the year 1801 and you discover Neptune and you discover Uranus and you discover Pluto and you discover literally freaking thousands of objects in the solar system, your discovery doesn't count unless you announce it. If you don't tell anybody, it doesn't count. But you discovered all of it. So that's kind of strange. Which means there are probably writings somewhere in some obscure journal locked away in some library, some really old library of men and women who were making discoveries all over the place, scientific discoveries that nobody ever mentions, that nobody ever talks about. But they wrote them down. But because they weren't announced to the world, then I guess they don't get credit for it, do they? But I'm sure there's a lot of that. I'm sure there are a lot of discoverers out there that really that really got the ideas out and nobody paid any attention to them, so they were just ignored and forgotten in the sands of history. And what that really does is really makes me think, because in stellar metamorphosis, the stars, they're protoplanets. They're young, hot planets that are too hot to evolve to the point to where they can host life like Earth. To make me think that if you were a caveman or a Neanderthal man in Europe and you looked up at the stars on a clear dark night, this theory literally states that if you were to notice they're there, you're the discoverer of them. But I'm pretty sure that they announced the fact that they had discovered them to each other. Look at those little bright things up there. What are those, So, do they essentially count as the people who discovered exoplanets? It makes me think, because it's like, well, if a star is a young planet and, a caveman and people that lived in like freaking 500,000 years ago, were they the real discoverers of exoplanets? It makes me wonder. And I'm not really sure if this is like a discovery, like this guy was discovering objects in the outer solar system, or if stellar metamorphosis is more or less an insight. I don't know if it's a discovery or an insight, or it's an insightful discovery, or if it's a discovery of an insight. I'm not really too sure what it is anymore. I've just been working on it for almost 5 years now, and I'm just kind of getting lost in the translation of all these ideas, and building the fundamental principles of this theory is turning out to be very interesting, because I'm beginning to connect all of them. But anyways, Mike Brown, I suggest reading this book and notice what he doesn't talk about. Notice how he doesn't really refer to the physicality of the object. He only concerns himself with a lot of the paperwork stuff and programming the computers to find these things, and looking at computer screens, and not really trying to like get to the physicality of what it is he's looking at. I know it may sound kind of weird, but I don't think astronomers are really prepared to be able to look at objects and like kind of see through them, if you will, to see their deep history. I think stellar metamorphosis is going to allow people to do that. But astronomers, what they usually focus on is their appearance, how much of an albedo, how reflective the surface is, or how far away it is, or, you know, they're not really concerned about the physicality of it. I guess to really get that down, they should work with heavy machinery. Like, for instance, I sometimes drive a forklift at work. And I know that if I drive the forklift into a little sand pit or on the ground, not on concrete, the forklift will sink just a little bit, and it will be hell to try to pull it out of that little sand pit. I haven't done it yet, but I always need to make sure I stay on concrete, because the concrete displaces all that mass and can support the forklift's weight. But to know how heavy and understand how heavy something like that is, and then to look at the Earth and imagine inside the Earth there's this giant iron core that's billions of tons, billions of battleships worth in iron and nickel. And to see the Mike Brown and astronomers completely ignore that, I'm like, do they understand what it means to be massive? I don't think they do. Or otherwise they would have, you know, he would have mentioned it in that book. But I think this talk is long enough. It's one of my longest talks in a while. All right, y'all, take it easy.